Hey there guys, welcome to the video for Unit 3. This is going to be covering graphing linear inequalities, which are problems 3 and 11. Now to start off with graphing linear inequalities, it's similar to graphing linear equations in that we start with the y-intercept. Your y-intercept is always the number being added or subtracted to the x without an x. So it's the constant by itself. In this case, since I have a plus 1, that means my y-intercept is 0, 1. Which means my first point, denoted by the pink point, is going to be my y-intercept and where I start to make the rest of my points. So I will start with 0, 1. So that's my pink point. To get the rest of the points, these black points, I'm going to use the slope. Now the slope you find by the coefficient or the number in front of x or touching x. Now in this problem, we're originally just given negative x. Well, I know that when an x is by itself, it has an implied 1. So when a negative x is by itself, it has an implied negative 1. But when we write slope, we like to do rise over run. So I know I can turn any whole number into a fraction by writing it over 1. So my slope is negative 1 over 1. All I did was I took this negative 1 from my slope and wrote it over 1 so I can have a rise and a run. Now, since my rise is a negative 1, I know rise goes up and down. And since it's negative, I'm going to go down 1. And since this run is a positive 1, run goes left and right, positive 1 will be right. So you're going to go down 1, right 1. So from your pink point is where you create the rest of the points. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth. I could also go up 1, left 1, up 1, left 1 to get the rest of my graph. And you can check your answer by saying, okay, well, this graph tells me I have a negative slope. So I should, after writing my points, have points that create negative slopes. And in this case, we do. We decrease going from left to right, or we're going to go down a staircase, or down a hill, going from left to right. Now you'll take the straightest to connect them. Now, if this was just graphing equations, you just automatically connect them. But this is graphing linear inequalities. So we have to take a moment and pause and consider my inequality. Now my inequality has a bar. It is equal to, which means I have a solid line. If that bar underneath was missing and it was only greater than without the bar, then that's when I would use a dashed line. But since I am equal to, I can include the line. Now I have to consider, okay, am I going to shade above or am I going to shade below? Well, in this case, I am greater than. Since I'm greater than, it makes sense that you will be shading above. Now, if you struggle with knowing what sides above and below, there's different ways of thinking about it. One way is thinking my y-intercept. What numbers are above my y-intercept? Well, 2, 3, 4, 5, so on and so forth. So this is my above. You can also draw arrows pointing above to let you know this is my above section. Now be careful, when we say shade above, we mean shade above the line connected by our points. So not just above the x-axis, all this section above this line. You do not have to draw these arrows on your test, but it may be helpful for you to determine what side's above. Now going on to number 11. Number 11, we have y less than negative x minus 4. So once again, we always start for this one with finding my y-intercept. My y-intercept is the number being added or subtracted to my x. In this case, it's not just a 4, it is a negative 4. So my y-intercept is negative 4. So I'm going to look at the y-axis, and I'm going to look for a negative 4, which it is here. My pink point is my starting point. You always start at the y-intercept. Similar to before, my next step is to find my slope. Now, they don't give me a number. Usually, they'll give me a number, and that's what the numbers I'll put here. If it's a fraction, you'll put the fraction. If it's a whole number, you'll put that whole number over 1. Here, you have to recognize, similar to before, when x is by itself, it has an implied 1. So my slope is negative 1. And I can turn any whole number into a fraction by writing it over 1. So similar to before, since my rise is negative, I'm going to go down. Since my run is positive, I'm going to go left. So down 1, left 1. Down 1, left 1. And I run out of space, so I stop here, go the other direction, up 1, left 1, up one, left one. So I'm going down and right and up and left. And you should see it creates a straight line. Also, you would double check to say, okay, well, did I draw a negative slope? Yes, this slope is going downwards from left to right. You're going down the staircase from left to right. Now be careful, a lot of students will just want to automatically connect these points, but remember, we're graphing linear inequalities, so we have to look at it. Looking at it, this time it is less than. I know it's less than because it does not have the mouth pointing towards my y. Since it's less than, and it has no bar, notice it does not say equal to, this time we're going to have a dashed line. Dashed lines are created by leaving spaces or gaps between my line. So this is a dashed line. Once again, it was a dashed line because we do not have the bar. It is not equal to. Then we mentioned earlier that is less than. Less than, it makes sense, is shade below. Now if you're trying to determine what side's below, you can draw arrows pointing downwards. This is my below section. And it's below the line, so everything below the line. So this entire section here. And you're done graphing. All you have to do is, similar to before, start with your y-intercept, use your slope, then either connect with a solid or a dashed line, and then shade either below or above. Those are the problems from your review. If you have questions, feel free to sign up for tutoring, or feel free to email your teachers.